Green hydrogen is definitely one of the options to improve the carbon footprint of steelmaking. To understand how, a short explanation about steel and its production process. Steel is an alloy of carbon and iron is obtained from iron ore, which is a strong combination of iron and oxygen. Thus, to get pure iron, you need to split iron ore into iron and oxygen, using both a huge amount of energy and a reductive agent. Since the first age of metallurgy, the main reductive agent has been carbon. To be precise, carbon monoxide, CO. But hydrogen could play the same role, with a great advantage: it can be carbon-free. Indeed, reducing iron ore using CO or using hydrogen as a reductive agent has two big differences. The reaction with CO releases heat when the reaction with H2 consumes heat. But more important, the reaction with CO releases CO2 when the reaction with H2 releases only water. The challenge for steel is thus to replace carbon monoxide by green hydrogen. But how do we produce steel today? There are three main production routes. The first and mostly used is the blast furnace route. 71% of steel is made using this process. Layers of iron ore and coke from coal are loaded at the top of the furnace. Hot air enriched with carbon-containing fuels is introduced through pipes. And thanks to the generated high temperature, iron ore is reduced and becomes liquid pig iron. Similarly, the impurities contained in the iron are also liquefied to create the slag that is floating above pig iron, thanks to the lower density. A modern blast furnace can produce up to 11,000 tons per day. CO2 is generated in the exhaust gas, leading to an average of 2 tons of CO2 per ton of steel. The second production route is recycling metallic scraps. It counts for about 24% of the global steel production, and scrap in that case is loaded in an electric arc furnace, where the arc, which is in fact a plasma, will heat up until the liquefaction. The carbon footprint of this route is around half a ton of CO2 per ton of steel. And there is a third production route that today counts for about 5% of the global steel production. This route is named DRI for direct reduced iron. Direct because the reduction is done in the solid state. Iron is prepared in small balls named pellets, and these pellets are loaded at the top of a vertical shaft furnace. In the bottom, a syngas made of CO and H2 is introduced. This gas is produced from the reforming of natural gas. Both gases, CO and H2, take part to the reduction of iron oxide, and the exit product is DRI, small balls of quasi-pure iron. And a modern DRI unit can also produce few thousand tons per day of reduced iron. And this iron can be transformed into steel in an electric arc furnace. The carbon footprint in that case is around 1.1 ton of CO2 per ton of steel, which is half of the blast furnace route. How could H2 make steel production more sustainable? The first way would be to replace existing blast furnace by DRI. As explained, the use of hydrogen in the steel production route allows for a reduction of 50% of CO2 emissions. This is what many steel producers have planned. And the second way is to enrich the syngas used in the DRI furnaces with more green H2. When increasing the part of this green H2, carbon monoxide could be eliminated. And this is what the steel makers intend to do in the second step. And for instance, the substitution of 30% of natural gas by green hydrogen could reduce the CO2 emissions up to 250 kg per ton of steel. The full substitution could bring the CO2 emissions below half a ton by ton of steel. According to the level of substitution of the production routes, the green hydrogen needs could range from 30 million tons per year to above 60 million tons per year for the full steel sector, and making the steel sector one of the major green hydrogen consumers. This will require huge hydrogen production capacity. Just imagine, for 1 million tons of steel using the DRI route, 400 to 450 megawatts of electrolysis capacity would be needed. This gives great opportunities for green hydrogen platforms.